In this video, I want to look at regression, in particular what's known as the method of least squares, which is the most common method of regression. The idea is if I have a scatter plot, I want to find the best fitting line for this scatter plot. So I know that it is a linear correlation and I want to find the best fit line to model this data. As an example, here I have a scatter plot and I have 3 lines here, so which one of them best fits this data? So this is what we're trying to find when we talk about regression. So what we're going to look at is we're going to look at a line. We have our points and we're going to find these distances between the observed value, the actual point, and the predicted value, what the line says it is. These points right here are going to have a positive error. These points down here are going to have a negative error. And what our goal is to find the line that minimizes the square of these distances. So this is why it's called the method of least squares. I want to think about d1 squared, I want to think about d2 squared, d3 squared, etc. And I want to minimize this total sum. I'm going to find all of these, add them up, and then I want to make it as small as possible by changing the line until it is as small as possible. So this is the idea of the method of least squares. Ultimately, my goal is to find an equation of a line that looks like a plus bx. And this can be really difficult to do by hand, so we are going to use R to figure out how to do this. Using the command LM and then Y tilde X $COEF does give these values for A and B. And we can use this command AB line of LM of Y tilde X to graph the regression line. And we can change the color of this just like we could change the color of all of our other graphs. So let's look at some examples of this. In a previous video on correlation, I graphed this chest girth versus weight in bears. And now I want to add the correlation line. I'm going to start by using the command lm of weight tilde chest.g $COEF. This gives me my y-intercept and my slope of my line. So the line is y equal to negative 2.93.05844 plus 13.17127x. I'm then going to use the command AB line of lm of weight tilde chest.g, and I'm going to change the color to blue, and now I can see my regression line here on my graph. So now I not only have the equation, but I do have the actual line on the graph. Here's the equation of the line I just found in RStudio. I used W for weight and G for girth. So we know that the equation was negative 293.06 plus 13.17 G. So we can use this to make predictions. Let's suppose we have a bear and we know its girth is 35. Well, then we can plug that into this equation and get an estimate for the weight of this particular bear. And if we do, we get the estimated weight is 167.89 pounds. And that doesn't mean it's going to be exactly 167.89 pounds, but it does give us a fairly decent estimate of what the true weight of this bear is. And the better correlation we have, the stronger of correlation, the more accurate this estimate is going to be. It can work the other way too. If we know the weight of a bear is 300 pounds, we can figure out an approximation for the chest girth. And I'm not going to solve this equation, but here we have just a very basic linear equation that we would need to solve. So this regression is very helpful for making future predictions about our particular data set.